Hey guys, it's Cy. If you're super curious but don't always have the time to watch your favourite podcasts, you found the right place. Here's your summary of Lex Fridman number 445 featuring Adam Frank. In less time than it takes to bake a cake. Let's jump in. Spanning 3 hours, this podcast with Lex and Adam Frank dove deep into a lot of interesting topics from UFOs and extinction events to the nature of time. Adam Frank is an esteemed astrophysicist known for his work on star systems and the search for extraterrestrial life. In this episode, his passion for understanding the cosmos is palpable as he discusses his journey from a curious child to a leading scientist. Frank has written several books, including The Little Book of Aliens and Light of the Stars, which delve into the science and philosophy of our place in the universe. Lex Fridman introduces Frank by highlighting his contributions to astronomy and his role in popularizing science through literature. Adam Frank is an astrophysicist studying star systems and the search for extraterrestrial life and alien civilizations, Lex states, setting the tone for a deep dive into cosmic questions. Frank shares anecdotes from his early life that sparked his interest in the stars, emphasizing how his childhood curiosity led to a lifelong career. The conversation begins with a light-hearted exchange about the beauty of the night sky, which Frank describes as the most profound natural wonder. The discussion on planet formation kicks off with Frank explaining the basic mechanisms behind how planets come into existence around stars. He details how dust, gas, and other materials coalesce over time under the influence of gravity. Frank uses the example of our solar system to illustrate typical planet formation processes, noting, planet formation is essentially a cosmic dance of gravity and chemistry.
Once you get into the disk itself and you want to do planets, things get a little bit more complicated because the physics gets more complicated. Now you got to start worrying about dust, because actually dust is the wrong word. It's smoke, really. These are the tiniest bits of solids. They will coagulate in the disk to form pebbles, right? And then the pebbles will collide to form rocks, and then the rocks will form boulders, et cetera, et cetera. That process is super complicated, but we've been able to simulate enough of it to begin to get a handle on how planets form, how you accrete enough material to get the first proto-planets or planetary embryos, as we call them. And then the next step is those things start slamming into each other to form, planetary sized bodies. And then the planetary bodies slam into each other. Earth, the moon came about because there was a Mars-sized body that slammed into the Earth and basically blew off all the material that then eventually formed the moon.
They explore the different types of planets, from gas giants like Jupiter to rocky worlds like Earth, discussing their unique characteristics. Frank also touches on recent findings from telescopes like Kepler, which have expanded our understanding of exoplanets, suggesting a vast diversity in planetary systems beyond our solar system. Lex and Frank ponder the implications of these findings for life elsewhere in the universe, with Frank stating, "Every new planet we discover reshapes our understanding of what's possible." Adam Frank explains how the dynamic geological processes of Earth, particularly plate tectonics, are crucial for life. He discusses how continents move, collide, and separate over geological timescales shaping our planet's surface. Plate tectonics is what makes Earth a living planet, Frank asserts, emphasizing the role of these movements in creating diverse environments for life.
We think plate tectonics may have been really important for life on Earth, for the evolution of complex life on Earth. So it turns out, and this is sort of the next generation where we're going with the understanding the evolution of planets and life. It turns out that you actually have to think hard about the planetary context for life. You can't just be like, oh, there's a warm pond, and then some interesting, chemistry happens in the warm pond. You actually have to think about the planet as a whole and what it's gone through in order to really understand whether a planet is a good place for life or not.
They delve into how these processes have influenced Earth's climate, atmosphere, and even the evolution of species. Frank provides examples like the formation of mountain ranges, the opening of ocean basins, and the recycling of the Earth's crust. They also touch on how this understanding helps in the search for habitable planets outside our solar system, where similar geological dynamics might exist. Frank outlines the history of mass extinctions on Earth, highlighting how these events have dramatically changed the course of life. He mentions the famous Cretaceous-Paleogene extinction event that wiped out the dinosaurs, opening the path for mammals. Extinction events are not just ends, there are also beginnings, Frank notes.
Because it's certainly true that we have gone through almost extinction events, right? We've had, 5 mass extinctions, but you don't necessarily see that like there was this giant evolutionary leap happening after those. So, with the comet impact, the KT boundary, certainly, lots of niches opened up. And that's why we're here, right? Because, our ancestors were just little, basically rodents, rats, living under the footsteps of the dinosaurs. And it was that comet impact that opened the route for us. But
offering a perspective on how life has rebounded after each catastrophe, they discuss the role of asteroids, volcanic activity, and climate change in these events. Frank explains how studying these past events helps predict future risks to Earth's biosphere. They also consider how such events might occur on other worlds, potentially affecting any life there. The conversation explores the resilience of life and its adaptations post-extinction. The biosphere is discussed as the global sum of all ecosystems, where Frank elaborates on how life interacts with Earth's air, water, and land. He describes the concept of the biosphere as a thin layer of life that makes Earth unique in the cosmos. Frank talks about the feedback loops between life and the environment, like how photosynthesis has changed our planet's atmosphere. The biosphere is this incredible, self-sustaining system, he remarks, emphasizing the complexity and interconnectedness of life.
The idea of Gaia theory was that life, the biosphere, exerts this pressure on the planet, or these feedbacks on the planet, that even as other things are changing, the planet will always stay in the right kinds of conditions for life. And now, when this theory came out, it was very controversial. People were like, oh my God, what are you, smoking weed? And like, there were all these Gaian festivals with Gaian dances. And so, it became very popular in the New Age community. But Lovelock, actually, they were able to show that, no, this has nothing to do with like the planet being conscious or anything. It was about these feedbacks that by the biology, the biosphere can exert these feedbacks.
They explore how human activity has begun to alter this balance, potentially leading to a new geological epoch termed the Anthropocene. Frank also speculates on how biospheres might look on other planets if they exist. Introducing the technosphere, Frank describes it as the human-made systems and structures covering the Earth, from cities to the internet. He explains how this new layer of human activity impacts the biosphere, often in unintended ways. The technosphere is our footprint on the planet, Frank states, discussing the scale and speed at which human technology has reshaped the Earth.
Now, we just invented this technosphere in the last, couple of hundred years. And what we were arguing in that paper is that it's an immature technosphere, right? Because right now, with climate change and all the other things we're doing, the technosphere right now is sort of destroying the conditions under which it needs to maintain itself. So the real job for us, if we're going to last over, geologic timescales, if we want a technosphere that's going to last tens of thousands, hundreds of thousands, millions of years, then we've got to become mature, which means to not undermine the conditions, to not subvert the conditions that you need to stay alive. So as of right now, I'd say we're not autopoietic.
They talk about the implications for sustainability, energy use, and global climate change. Frank offers examples like the global spread of plastics, the alteration of natural landscapes, and the digital information network. The conversation ponders whether future civilizations might leave similar technological signatures on their planets. The emergence of intelligence is explored through the lens of evolutionary biology and the potential for intelligence in the universe. Frank discusses how intelligence might be an evolutionary inevitability or a rare fluke. Intelligence is one of the universe's greatest experiments, he says, contemplating why not all species evolve brains capable of complex thought.
I got to ask you about this paper.
Right.
Pretty interesting. There's an interesting table here about hard steps. Abiogenesis, glucose fermentation to pyruvic acid, all kinds of steps, all the way to Homo sapiens, animal intelligence, land ecosystems, endoskeletons, eye precursor, so formation of the eye.
Yeah.
Complex multicellularity.
That's definitely one of the big ones.
Yeah, so interesting. I mean, what can you say about this chart? There are all kinds of papers talking about what the difficulty of these steps.
Right. And so this was the idea. So what Carter said was, using anthropic reasoning, he said there must be a few very hard steps for the evolution to get through to make it to intelligence. But what we actually found was that none of those are actually hard. The whole idea of hard steps, that there are hard steps, is actually suspect. So
They look at milestones in human evolution that led to our current state of intelligence. Frank also speculates on the forms intelligent life might take on other worlds, considering different biological and environmental constraints. This topic delves into the philosophical implications of intelligence in the cosmos. Frank and Fridman discuss various methods used in the search for extraterrestrial intelligence, including radio signals and biosignatures. Frank outlines current projects like SETI, Search for Extraterrestrial Intelligence, and the use of modern telescopes to look for signs of life. We're listening for the whispers of the cosmos, he notes, illustrating the patience and technology involved in this search.
And SETI, the classic idea of SETI is the radio telescopes, and Contact, Jodie Foster with the headphones. That whole thing is still it's still active. There's still great things going on with it, but suddenly this whole new window opened up. When we discovered exoplanets, we now found a new way to look for intelligent civilizations or life in general in a way that doesn't have any of the assumptions that had to go into the classic radio SETI. And specifically what I mean is we're not looking for somebody sending us a beacon. You really needed that with the classic model for a bunch of different reasons. You had to assume they wanted to be found and they were sending you a super powerful beacon.
They consider the challenges of detecting life across vast distances and the potential for false positives or negatives. Frank also shares his thoughts on the philosophical impact of discovering alien life, how it might change our view of ourselves and our place in the universe. Wrapping up, Frank and Fridman delve into the philosophical and scientific understanding of time, particularly how it relates to the universe's history and future. Time is not just a clock ticking, it's the very fabric of our reality, Frank explains, discussing concepts like entropy and the arrow of time.
Hearing music, you're both already anticipating what's going to happen and you're, remembering what's going on. There's a kind of phenomenal structure there, which is different from the representation of time that you have with the formal mathematics. And what, the way we would look at this is that the problem with the surreptitious substitution, the problem with the blind spot, is it says, oh, no, the formal system is time. But really, the only place time appears is with us, right? We're time, So having a theory that actually could start with us, and then stretch out into the universe rather than imposing this imaginary third-person view back on us, that's a route towards a different way of approaching the whole problem.
They ponder whether time could be different in other parts of the universe or in other dimensions. Frank brings up theories of time in physics, including relativity and quantum mechanics. They discuss how our perception of time influences our understanding of the cosmos and our search for meaning within it. The conversation ends with reflections on the human condition, time's passage, and our brief moment in the grand timeline of the universe. And that's that. In wrapping up this enlightening conversation, it's clear that Adam Frank's insights push the boundaries of our understanding of the universe, from the microscopic interactions within our biosphere to the grand cosmic dance of planets and stars. The discussion not only delves into scientific exploration, but also touches on the philosophical and existential questions that arise from contemplating our place in the cosmos. Frank's perspective on the emergence of intelligence, the impact of human activity on Earth, and the ongoing search for extraterrestrial life invites us to reflect on our responsibility towards our planet and the potential for life elsewhere. If you learned something new and want to spread some love, we would really appreciate if you hit the bell icon to get a head start on new episodes uploaded every other day. Make sure to like and subscribe and comment below if you think aliens are real. If you want to stay updated, head on over to X and give us a follow at solutionsai_. All links are super easy to find down in the description and pinned to the top comment. We'd love if you share our stuff with your friends and family too. And most importantly, be sure to stay curious. See you next time. Sci out.